When it comes to terms, we're going to start with one of the most familiar terms, distance, right? We all know what distance is as a quantity, but I'm just explaining it over here. Now let's consider the axis, okay, the reference frame. Let's consider our ball, and the ball moved 30 meters towards the right, which is plus, and then it moved backwards or towards the left, it moved 10 meters. So it came back 10 meters. What is the distance traveled by the ball? It's a no-brainer. The distance would be equal to 30 meters plus 10 meter, which is equal to 40 meters. So the distance traveled is 40 meters. The length of the path traveled by the ball is 40 meters. The distance is the length of the path traveled. Now let's say, instead of traveling to the right, the ball traveled backwards or traveled to the left. It went 30 meters backwards and then 20 meters forward. What would be the distance traveled? It would be the same. Again, 30 meter plus 10 meter. The path traveled, the length of the path traveled by the ball. Distance is 40 meter. Okay. The second term is more interesting. It's displacement, and probably it's more useful for us when we try to measure and describe motion. It's called displacement. Displacement is the change in position. That is, final position minus the initial position, the change in position. So let's take this same scenario and say, what is the displacement? And displacement we see is, as I said, I'm going to call it delta x, final position minus the initial position. What is the final position? Plus 20. What is the initial position? It started from 0. So displacement is equal to plus 20. Final position minus initial position. Now here's what I want you to know. Let's say we consider the ball traveling backward. The ball travels backward 30 and then forward 10 and it stops here. What is the displacement? So we look at displacement. Final position minus initial position. So the final position is minus 20. Right? We're describing the position and it is to the left. So it's minus 20. Minus initial position was origin, which is 0. So we say displacement is minus 20 meters. So displacement can either be positive or negative. So not only does displacement have a magnitude, it has a sign. It has a direction. It's either in the right direction, towards the right or towards the left. It has a direction. Such a quantity, which is both magnitude and direction, is called a vector quantity. I want to keep this in mind. We will go in detail in vector quantities later, but I just want you to keep in mind the difference between displacement and distance is an important difference. Displacement has both magnitude and direction, whereas distance, it was positive and it just had a magnitude, right? Just to make things a bit more clear, let's take one more situation. Let's say the ball was sitting at 40 meters. The position was plus 40. It came back to plus 10. It traveled leftward. What is the displacement? We see displacement is equal to final position. I'm taking up x2 minus x1, which is the final position is plus 10. The initial position is plus 40. 10 minus 40, which is equal to minus 30. That means a displacement of 30 meters has happened. The initial position and the final position, there is a change of 30 meters. And it is minuses, it is in the leftward direction. Right? So 30 is the change in position, minus means it's towards the left. Right? So displacement is the magnitude of the initial position, final position minus initial position with the direction.